Hi everybody, welcome back to the track number 5. This is the second class of this track. My name is Anibal Azevedo and I'm gonna talk now how we can apply artificial intelligence techniques to the context of the container port operations. The just we justify this work since we saw that's possible to apply very interesting things, very interesting coding using Python and using very simple way to model the problem and to avoid complexity, but solving the problem. So let's see what we are going to develop here. We are going to develop some quake crane rules, how you can operate quake cranes in a feasible way, and how you can get different ways to operate a quake crane. So what we're gonna start now is just to remember what we saw in the previously track, in the previously class. So if you didn't saw the previously class, it's very important because we saw some details of this project. What is the context of this project? So we're gonna use quay cranes to operate or to load or to unload cargo from a container ship. What's very important in a container ship? It's container ships are very high dimension, very large equipments are needed to operate or to move containers. So these equipments has some properties. For example, they should keep a minimal distance between them for security, for reasons, and also these equipments could not overpress. One crane could not jump uh, from to another bay of a ship since they are very big and they are very rail mounted. So what we can say, why it's important to consider the operations of quay cranes, because if you are trying to count the total time that the ship will spend in the port, it's not enough to say, oh, this ship will have to move or three containers, four containers, load or unload. How many containers? It's not that important, and we're gonna see this exactly in this picture. Imagine that we have a quay crane number one here, and if we decide to operate this quay crane to move in this direction, and this second quay crane operate in this direction, we're gonna start in the time 0, and it seems to be a very good idea uh, performing the operations like that. Okay, so this quake crane start to removing three containers here and one container here. Remember that we are not counting that the time to move from uh, from one bay to another is just two gonna spend two units of time. So in the time one, this quay crane 2 already finished the work on this bay of the container ship and gonna get to this direction, okay? So this bay is not free. This workload now is 2, but this quay crane is not done in terms of work. So when this quay crane to move, this quay crane spends 2 units of time, but when they started to perform some operations at time 3, we get this. This quake crane should stay here, cannot help in the operation of removing or moving containers exactly here. And you have just to stay. This quake crane ends here, and this will end at this time. So we are not considering the time to move to another bay. But what is very bad here is that we have to move some quay crane for there for this place or this place, and the other quay crane should move to this bay to finish the process of loading or unloading container ship. So it's a very, very bad uh, way to do this, because we just this kind of locking of equipments, the equipments just have to wait to finish the process. So it's not an optimized way to do the thing. So we can improve this. So how we gonna use this the movements of how we're gonna say how much effort we should do in each bay? It's very simple. Imagine that each we are in a certain port of the ship is in a certain port. For example, in port one, on the port two, three, and four. This is the evolution of the container ship through ports. Okay, so we use this transportation matrix, and we get this kind of containers arrangement inside a container ship. So this is the unloading phase, and this is the loading phase through ports. It's a very, very simple container ship. Okay, so what's important here, imagine that this stack represent a bay. It's a simplified way. Okay, and this another stack represent another bay, and so on. So now we're gonna have the planning phase and the operation phase in a part one. So instead of seeing all the bay in detail, we're gonna just see how much effort we should perform in this bay. So imagine that we should load all containers. So we're gonna spend free movements here and free movements in this bay and so on. So this is the total workload per bay in the loading operation. We can spend this by, imagine that we have loading and unloading operations here, okay? Um, what's important here, you imagine that the container ship starts with some containers that we should uh, unload and before load, and we can get this pattern of moving and removing containers through ports, right? So what's important, we can extract this pattern from each port, and then we can apply some rules to operate quay cranes in terms of loading and unloading operations. So imagine now that we have this pattern. The quay crane one starts in the first bay, and the second quay crane starts in the middle of the container ship. This is the situation time zero. And obviously, the first quay crane will have done the work in time 3, and the quay crane 2 are still processing the third bay, and time 4 they can move together, because we have a special situation where this quay crane should stay here and wait to the crane to end this task. Okay, so when we got a kind of synchronization, we call this a synchronization of operations, and they move together. So they should keep the minimum distance, and they move together to the next bay. So in the time 5, the second crane will finish this operation, and in time 6, the crane 1 will finish its operation. So another way to think this is just to this rule second that we're gonna apply, also that we're gonna use also. And what is the difference between the rule 1 and 2 is because the rule 2 will allocate the quay cranes in different positions. So the quay crane 1 will be not exactly in the middle, but just a position before the middle in the second bay, and the second quay crane will start in the last bay. So we always move the quay cranes the same direction. Not here, but we always move the two quick cranes in the same direction. That's the most important thing. The quick cranes cannot move in different directions because this is not a good idea. Okay, so they all move to the left now. They both quake cranes will move to the left or to the right. We have an article that proves that using the same direction for the all quake cranes, we still can get the optimal solution for this problem. We have an article that proves this. Not we, but where someone published an article that says, "Oh, proved this mathematically." Okay, so what's important here? Okay, this quake crane just finished the work in the last bay, and then they got synchronized. This quake crane should wait this second quake crane, and this time too they move together. And when we finished all this, we got the time number 6. Okay, so what's important here? We get the same time here that we saw in the first rule. So we can, as you can see here, we have multiple ways of doing the same thing with the same time, but in some situations the time is not the same. So depending on how you position your quake cranes, the total time will be different. But sometimes it is depending of the configuration that you have. Sometimes doesn't matter on how you can position on of the rule that we are applying to position the quake cranes is not important, but sometimes you can get different solutions in terms of total time. Okay, so that's the end of the overview. In the next class, we're gonna see how we can, how is the code using these situations of blocking. So we're gonna use these slides to see, oh, this is the case where we have this situation in the algorithm is described exactly here. So it's a different way that we are doing previously videos because I understand that now we have enough maturity to understand the code. I hope after doing this work, you get some maturity about Python code, Python classes, and about the problem also. So this is a more dynamic way of seeing the things. So thank you for your attention. I hope you find this video interesting and useful, and see you in the next video. Bye.